Good morning, guys. Today we're going to be continuing the topic of graphing inverse functions, but today we're going to focus on domain restrictions. And so if you remember, I had mentioned that we were going to talk more in depth about domain restrictions because it has more of a graphical interpretation. Like it's easier to notice where the restriction should go or what should be restricted, because graphically you can see if something is reflected correctly or if it's not reflected correctly. Okay, so we're going to be using the same skills that we've used to graph from when we were graphing transformations, but we're also going to be learning about how to restrict a domain uh, of either an original function to ensure that the inverse is a function as well. So we're going to be talking about the definition again. What does it mean for a graph or an equation to be a function? Okay, so let me move this up, and then we can read the intro. So if a horizontal line intersects the original graph in more than one location, we must restrict the domain. Okay, so in this picture, let me just draw arrows here, here, and arrow here, and here. So we have these two graphs. The blue one is the original, and so if the blue one is the original, right, and if I draw a horizontal line, it's going to hit the blue graph 2 times, more than one location. So that means we're going to have to restrict the domain of the original. And so again, let me highlight that we're talking about the original. We're going to restrict the domain of the original to ensure that the inverse will be a function. Okay, so I'm kind of color coding so we can kind of keep track of what's the inverse, what's the original. And remember we talked about before that there's a reflection line whenever we're graphing. In the last lesson we talked about when we're graphing that there has to be a reflection along this this dashed line that we call the line y equals x. So we can see that the graph in red does not pass the vertical line test. Remember, the vertical line test is if I draw a vertical line, it can only hit one time. But if I draw a vertical line, it's going to hit the red graph 2 times. So that means that the inverse is not a function. So let me pick a different color here. Let me choose pink because it kind of stands out. So if something does not pass the vertical line test, then it is not a function. If something does not pass the vertical line test, then it's not a function. Okay, so if I draw a vertical line here, it's going to hit the function here and here. So the red graph doesn't pass the vertical line test, so we can't say that the inverse is a function. So what we have to do is we're going to have to restrict the domain. And so we're going to look at how to do that in the examples. And it'll make more sense once we actually get into the process of it. So I'm going to let the process speak for itself. Okay. The next example, and again, let me fill in the arrows because there's an arrow here, there's an arrow here, and a red one. Okay. All right, so it says to restrict the domain, we want to cut the original function in such a way that what remains will pass the horizontal line test. Okay, so I'm going to color code again here in this statement. To restrict the domain, we want to cut the original function in such a way that what remains will pass the horizontal line test, ensuring that the inverse is a function. Trying to box these. There we go. And so we want to cut the domain, so that's why the original is x squared. In these two examples, the original is x squared. We know that x squared has a U shape. And so if I were to draw the original, I would kind of fill in the missing gaps here, and it would do something. Oh, I don't like the way I'm drawing this. But, nope. There we go. Over here, we draw this one. Okay. So what we're saying here is that if I graph the function x squared, it's a blue one here. It's a U shape, and it's x squared over here. It's a blue one. Okay, so what happens is I have the x squared graph, and I find the inverse of this, and it ends up being the square root of x. But the square root of x has this shape. Remember 1, 1, 4, 2. And so the reason we restrict the domain is the blue graph is not going to be a good reflection if I graph the whole blue graph. It's not going to reflect how I want it to reflect along this purple line. Right? Because if I pick, let's say this point and this point, yeah, we see a clear restriction, not restriction, but reflection between those 2 points. But this half doesn't have a reflection point because the square root function doesn't have a bottom half to it. It just has a top half. Or if you do a negative square root, we're just going to graph the bottom part. Reflection, right? Negative means reflection. But to focus again on here, if I graph the x squared graph, it's going to have a U shape. And if I graph the square root graph, it's going to have this shape. So which half of the quadratic of the x squared is going to make a good reflection for this red function? Well, the right half is a good reflection, so I'm going to erase the left half, or restrict the domain so that I'm only focusing on the right half. And so I'm saying, okay, I'm looking at the quadratic, but only the part that's from x equals 0 and greater. So from 0 to the right. Okay. Same kind of idea over here. I have the x squared graph is this whole piece, this U shape. And when I find the inverse happens to be square root of x. But I have to decide, do I want to pick, and let me draw the square root of x graph. Do I want to pick the positive one? This is the positive one, or the negative one, right? The negative means reflect over the x-axis, and so it goes down here. And remember, we talked about when we're restricting the domain, if it says less than, we're going to choose the negative one. And so that leaves us with restricting the domain in such a way that we're only looking at x values that are 0 and less. So only the negative x values. So only the left side of this graph. So here it's x greater than 0, it's the right half of the blue graph. Here it's x less than 0, it's the left half of the blue. And notice how 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 the blue and the red are a really good reflection along this line. This is like a mirror, and these two graphs are a reflection of each other, right? So again, if I pick, let's say if I pick just these 2 points right here, you see that they're the same distance away from the reflection line. Okay, so let's go ahead and work on one, and then we'll see what we mean. I'm explaining everything in this sense, but it makes more sense if we look at it and see how it works. At the bottom of the page, there's the steps that we used in the last lesson. Find the inverse algebraically, sketch the dashed line in purple, or yeah, you can pick up a color, and then pick one color for the original, and then one color for the inverse. And you can make sure that the color that you choose is the same for all the other originals, so that you can kind of get used to seeing, okay, I'm going to use this color for original and this other color for inverse. And for me, I'm picking blue for the original and red for the inverse. And for the reflection line, I'm using purple. That's how I color code mine. If you want to do it the same way, it's up to you. So let's go ahead and jump into the example. Example 1. And so we're going to look for the inverse. And so the steps for the inverse is change f of x to y. Copy everything else, right? And then the next step is switch the place of x and y. And then the next step is solving for y. So I want to get, the square root and the y by itself. So I want to get rid of the plus 2. So I'm going to subtract 2 on both sides. The x and the 2 can't subtract, so I'm just going to write them or bring it down. These 2's will cancel, and I'm going to be left with the square root of y. How do I cancel the square root? Oh, I've been using orange, right? So to cancel a square root, I square both sides, and so I end up getting x minus 2 squared equals y, because these two cancel each other out. That leaves me with y equals, just writing the y first, and then replace y with the f inverse notation. Okay, so this is my original, and the function that I got at the bottom is my inverse. But a side note, right? I'm not going to box the inverse yet. I'm just going to underline it, because we're going to restrict the domain. Again, we only restrict the domain on the quadratic function. So let's graph the original, the blue one. And so it has, using red, I should be using blue. So I have 0, 0, 1, 1, 4, 2, and 9, 3. And so if you have your graphing paper, this would be the original function, but we have a plus 2. So what does the plus 2 tell us that we're going to do? We're going to move up 2. So all these points I'm going to go up 2, and I'm going to erase the originals. So that way. Okay, and then I'm going to graph or connect. Excuse me. Oh. Okay. So this is the quadratic function. And then I'm going to draw the reflection line. So the reflection line is the diagonal. Okay. And then the next thing is graph the inverse. The inverse is a quadratic function, so it has a U shape, right? And x minus 2 means that we're going to go to the right 2. Actually, let me write that on top. So we're going to go to the right 2. So the inverse is going to be right here, 1, 1, 1, 1, and then 2 to the right and 4 up. 1, 2, 4, and okay. So I'm gonna zoom in here to the graph, so we can kind of focus on the graph, and I can kind of show you what we're doing here. So we would have the following graph, right? And then over here we would have the left half. I can keep going. It's gonna keep going. Okay, so the idea is that I have the quadratic graph, but do you notice that the original is not really reflected very well by the red, because the red graph has this kind of a U shape, but the blue only has, this part. So if I were to say, if I were to cut the U-shaped graph in half, which piece would you keep? Would you, let me see if I can color it white and then I'll undo it. Would you keep, so if I delete, let's say if I delete this half of the red, would that be a good reflection? Is this red a good reflection of the blue? No, right? So I don't want to delete the right half. Okay, what if I delete the left? Is that a better reflection? Is the red a good reflection of the blue? Yes. So that's what I'm going to delete, actually. See how far I can. Okay, so I'm going to delete that half. And then I'm going to white out spot here. Oh, not white out, sorry. Erase. Okay. So then, let me zoom back out. Uh-oh, Let me group it. Now let me zoom back up. Awesome. Okay. So we got that part down. Okay. So then we have to figure out which part of the red graph did we keep. We kept the right part. But it's from which x value to which x value did we keep. So what x value is right here on the red? It's 1, 2. So on my function over here, I'm going to write the restriction. And so I'm going to put comma, comma, x. And again, we only kept from x equals 2 and greater. So I'm going to put x greater than or equal to 2. And so this whole part here is my inverse. Okay, so again, we graphed the quadratic, but the quadratic had a U shape, and we only want to keep the half that makes a good reflection for the blue. And so what piece is that? Everything in red that's from x equals 2 and greater. From x equals 2 and greater. So from x equals 2 to infinity is what we're keeping from the red graph. Okay, let's try it again. Let's go to the next one. Yeah, that's all right. Okay, so the next one, we're going to change the g of x to y. Copy everything. Then switch x and y. And now we want to solve for y, but I want to get rid of the square root. So, or I can get rid of the negative. It's up to you. Let's get rid of the negative. So I'm going to divide both sides by -1. That's going to give me negative x. This is going to change to a positive. And so that's going to give me positive square root of y plus 5. And now I can say, okay, how do I get rid of the square root? I have to square both sides. That's going to give me, well, what's a negative times a negative? It's negative x times negative x. That's going to give me a positive x squared. And I'm going to be left with y plus 5 because the square and the square root cancel each other. And then to get y by itself, I want to subtract 5. So I can't subtract x squared and 5, so they're just going to be next to each other. And I get y. So I get y equals x squared minus 5, and then change it to the inverse function. Notice that the original is a g. They're using g instead of f. So for the inverse, I'm going to put g inverse notation of x squared minus 5. And so I have my original. I have the original, and then I have the inverse, and I'm just going to underline the inverse because again, I'm going to have to put a restriction on it. And again, we're only putting restrictions on quadratic. Okay, so let's see. The original, it has a plus 5 inside and it has a negative outside. So the plus 5 means that we're going to go to the left. And the negative means, where do I want to write it? Write it over here. It means reflect, but reflect where? Reflect over the x-axis. So remember, these are just things that we have to remember from transformations. And so, let's do it. So I'm going to do it in black and then move the points. So the original function is 0, 0, 1, 1, 4, 2, and 9, 3. So notice that I'm just graphing the original points in black, but they're going to have to be reflected. So on the x-axis, so they're going to be reflected this way. And then I have to move them to the left 5 units. So all these points are going to move 1, 2, 3, 4, 5. So right there's 1. There's 1. 1, 2, 3, 4, 1, 2. 2, 3, 4, 5. There. All right. So I'm going to delete or erase the extra parts. I'm going to use a thicker eraser. Okay, and then I'm going to graph this quadratic, but I mean this square root. And actually, let me zoom in because I want to make sure I draw it pretty good. So let me see here. That's better. Okay. I'm happy with that one. Okay, so let me zoom back out. All right. The next thing is going back now that we graphed the original, again, the original is reflected. So instead of going upward like this, it's going to aim downwards and go to the left 5 units. Okay, now let's look at the inverse. It's a quadratic. X squared minus 5 is outside. So that means, remember from transformations, that we're going to go, and again I'm going to write it on top. So we're going to go down 5 units. So if I graph the original, it's going to look something like that. And I can even do 3, 9 to be more accurate, right? And so I'm going to move all these points down 5 units. So it's going to go 1, 2, 3, 4, 5. And 1, 2. Okay. And then I'm going to erase the original points. And then I'm gonna zoom in. So I can focus on the graph. Okay, so to graph, something like this. Okay, awesome. All right. So again, oh, you know what? I actually forgot to graph the reflection line. So that, oh, sorry. So let me do that. Because the reflection line is important, and you can graph it after the original or after the inverse. It's up to you, because it's going to help you make the decision as far as, you know, what piece of the red graph should we keep, what piece reflects better. And so let's say I decide to remove the left half. So from here, you know, if I have the U, where's the U shape cut in half? It's right here. So let's say I decide to cut or to erase the left half. Right? So if I keep the right side, is what I have left of the right, is that a good reflection of the blue? I mean, take for example this point here, it doesn't have a representative over here, or in the blue, this point there's not a reflection point on the other side over here. So there's that aspect, right? So then I might not want to delete the I might not want to delete the left half. I might want to delete the right half. So let's see if I delete or erase the right half. Let me just put my settings back. So yeah, so let's say I delete the right half or erase the right half. Okay. So then we see that, you know, if I pick 2 points, or even just looking at the 2 points, if I pick this point and this point, these are a clear reflection, or it's the same distance away as this point. So these two points are a good reflection, as opposed to if I would have kept the right half. Because again, the quadratic is a U shape, and I'm deciding which half do I want to keep, right? So that the half that I keep is the piece that reflects the original. Okay, so let me zoom back out. And then let's come back over here and write down the part that we chose to keep. And so we chose to keep comma x. We chose to keep on the inverse. We chose to keep everything from 0 and greater than 0. I mean, sorry, everything from 0 and to the left. So everything from 0 and less than. Okay. Well, let's look at example 3. notice that in example 3, the original that they give me already has a restriction, because notice that the original is a quadratic. The original is a quadratic, and so quadratics have a restriction. Right, so let's find the inverse. Change the function name into a y. And then switch the x and the y. Right. So when solving for y, we want to get the squared part by itself. So I would move the minus 4, or get rid of the minus 4 by adding 4. I get x plus 4 on the left. These cancel. And I get y plus 3 squared. And then to get rid of the square, I have to square root both sides. That gives me the square root of x plus 4 on the left and y plus 3 on the right, because the square and the square root cancel each other out. Then to get y by itself, I need to subtract 3. Subtract 3. Let's cancel. I end up with the square root of x plus 4 minus 3 on the outside equals y. So rewrite it. I would write it as square root of x plus 4 inside. So x plus 4 is inside and minus 3 is outside. And then I would write in the inverse notation x plus 4 minus 3. So I have my inverse function here. All right, so let's graph the original. The original is a quadratic that has plus 3 inside. So that means we're going to go to the left 3 and 4 down. So to the left 3 and 4 down. That's my starting point. Again, it's a U shape. And the question is, what half do I want to keep? Do I want to keep, or do I want to keep the left or the right? Well, because it says greater than -3, greater than x equals -3, that's what I'm going to keep. Let me make a note here. This part is what I'm going to keep. And so I'm keeping everything on the right. I'm going to say right side. So I can erase, or let me actually connect the points. That's something like that. Okay, so I'm going to keep the right side, and so I'm going to erase everything on the left. And then I'm going to draw the diagonal line. But let me zoom in again. right, and then let's look at the inverse. So the inverse is saying or telling us to go to the left 4 and down 3. And so we have to figure out, are we going to have to put the positive or negative part down? So let's see. What happens if I graph the positive? Well, I have to go 4 to the left and 3 down. That's right there. All right, so 4 to the left, 3 down is right here. And let's say I graph the positive square root. And actually, remember from last time, if it's greater than, then we're going to keep it positive. If it's greater than, we're going to keep it positive. I'm trying to think of a different color to use here. I don't know. Let's say this one. Okay. Positive because of the greater than symbol. Okay, so it's 1, 1, 4, 2, and 9, 3. There we have it. The red and the blue are a great reflection of each other. Okay. The next part in the last example we have another quadratic, and so we have the original. And first thing we got to change the function into y, and we have x minus 1 squared minus 6. Switch the x and the y, and solve for y. So I'm going to add 6 on both sides. X plus 6 equals y minus 1 squared. Then to get rid of the square, I need to square root. I need to square root both sides. So I end up with the square root of x plus 6 equals y minus 1, because the square root and the square cancel each other out. And then adding 1 on both sides to get y by itself, because the negative and the positive will cancel. That's going to give me the square root of x plus 6 plus 1 equals y, or I can rewrite it as y equals the square root of x plus 6 inside, and then the plus 1 is outside. And then write it in inverse notation. So p negative 1 x equals the square root of x plus 6 and then plus 1 is outside. Okay, and so this is my inverse. But because, sorry, I erased it, and actually we have to put it over here too. But so let me erase it over here too. And the reason I'm erasing it is because we're actually going to make it a negative. we're making it a negative because we have, it's going to be a negative because we have a less than symbol. So it's going to be negative square root of x plus 6 plus 1 outside, and then negative square root of x plus 6 plus 1. Okay, so let's graph the original. Again, the minus 1 inside means that we're going to go to the right 1, and the minus 6 means that we're going to go down 6. So if I go to the right 1 and down 6, that would be here, that would be my starting point. And then to make the quadratic shape, you go 1, 1, 2, 4, and then too far on that one. That one should be right about here and here. Okay. So that gives me the following quadratic shape. Oh. And then we decide what half we're going to keep, right? Because this is the line that kind of divides it in half. That line is x equals 1. And we're going to decide what we keep based on this. This is saying keep the left side of the original. Keep the left side of the original. Okay, so if I'm going to keep the left side, that means I'm going to erase this half. And now let's graph. Let's graph this one. But let's graph the positive one. So let's say we didn't notice that this was less than. But let's graph the positive. So I'm going to erase this positive symbol here. I'm going to erase the negative to put a positive. And so let's graph. Let's graph this one. So this one's saying go to the left 6 and go up 1. So if I go to the left 6 and up 1, it's going to be, oh, I almost forgot. We got to graph the diagonal. Right, so let's graph the square root. We're going to go to the left 6 and up 1. So go to the left 6 and up 1. Be that graph. And so if we graph the positive one, it's going to be the following. 1, 1, 1, 2, 3, 4, 2, and then it's going to be the following graph. Oh, let me connect these a little bit better. So looking at the red and the blue, does it look like it's a good reflection? I mean, if I pick this point or any other point, if I pick a point on the blue, can I find it on the other side over here on the right? Right, and you would say, no, I can't really see that it's a reflection of the blue and the red. So we're going to think, okay, so then let's look at the negative option. And again, we're choosing that we're going to put a negative because it has a less than. So we're going to put a negative in front of the square root here and here. And that's going to change our graph here. So we're actually going to graph, and let me erase this red one, because we're going to graph something going the other way. Fill in that. Fill in this gap here. Okay, so then we're going to go to the left 6 and up 1. But instead of putting the dots going upward, we're going to go downward. Let's see what that gives us. So we're going to go down 1, 1, and then 4, 2, and then 9, 3. So I'm going to go there, and then I'm going to connect these points. Awesome. So then we see that this blue and this red has a better reflection. If this purple line is the mirror, then we see a better reflection with the blue and the red. So the reflection shows that the original and the inverse are true inverses of each other if we have a good reflection. And so this is why we should be able to figure out, am I going to put a positive or negative for the square roots based on the graph? Is the reflection line showing a good symmetrical comparison, right? For example, so if I pick this point and this point, are they the same distance away to the reflection line? And they are. They're a reflection image of themselves. Awesome. Well, thank you for joining me in this video. And if you have any questions, again, we're going to go over it in class. You can bring up any questions you have there. And have a great rest of your day.